So, just to go over the highlights of sections, 9, 9, 5, 9, and 6, the things that I want you to know is, ever so often we're going to be using these inner classes, which you haven't really seen before. So in Java, you can define a class inside another class, and there's two places where you can do that. You can put it on the top level and the same level as the methods, or you can put it inside a method. And so you will generally want to do that when you have small helper classes. So as an example is a comparator. So here I want to sort an array of strings by length, and I want to use arrays.sort. Why do I want to use arrays.sort? Because I don't want to write my own sorting algorithm. So arrays.sort, by default, it's perfectly willing to sort strings because strings implement comparable, but then it'll sort them in dictionary order. And let's say that's what I didn't want. I want the short strings first and the long ones later. So I would build my own custom comparator. And so if you now look at down here the code for sort, so I call arrays.sort, I give it the array that I want to sort, and then I have to give it a comparator object. What comparator? Well, it's a new comparator never seen before by human eyes. I have to implement it, and it's just an itty-bitty class. It's this class here. The class length comparator implements comparator, and then there's one method. It's one line long. And so here, the idea is, because it's such a small thing, you don't want to have to make a new top-level class, because it just goes under in the other 10 or 20 or 100 classes that you have in your project. This class is only needed here, so you define it right where you need it. And that's kind of all that's to it when you use inner classes. They're used for small things that you just want to put close to where you need them. That way you don't have to come up with an exciting name for them. Because if someone else has the bright idea of calling this length comparator, it's okay. That's in their class, and yours can be in your class. So you can have short and easy names. You can hide them. No one else needs to know that they even exist. And you would use these for these kind of tactical classes. And now, in the book, it explains the next step, and I'll briefly show you what that next step is, because you're going to be seeing it again in 151, even though right now we're not really going to go that far. So when you look at this line here, arrays.sort, then we have an array called names, and then I'm passing it an object, new length comparator. It's an object that was obtained by calling the constructor. And notice that object in red has no name. It's an anonymous object. I could have given it a name. So here I'm writing the code, giving it a name. I'm making the new length comparator. I'm storing it in an object I call Fred. And then I pass Fred to arrays.sort. But there's no point in calling it Fred if I only need it once. I mean, the point of giving a name to an object is if you need to call it multiple times. That way you always can't call the same one. If you meet someone only once, there's no need to know their name if you'll never meet them again. And it's the same thing with an object. So, in fact, even more is true. That length comparator class, I'll never want to see the thing again, ever. Why even call it length comparator? I just want a comparator that has this method. And so you can, in Java, even leave the name of the class anonymous. So here, as the second parameter to arrays.sort, I'm putting in some new comparator, and I don't even want to give the class a name. And the comparator, the way it functions, is spelled out here. It compares two strings by length. So that's called an anonymous class, and it makes for a much more concise syntax. That way I can write down what I want to write down without having to write a lot of Java code, and that's considered a good thing. So we won't use it here, but you'll see this a lot in 151, and so just as a preparation for it. You will see it a lot in professionally written code. It's a very common thing. All right, so let's do a clicker question. I need to set it up, which I was going to do on the network, but I'll do it in real time here. So, can we read the whole question? No. Okay, now you can read the whole question. When you read through the question while I set it up. But no, I can't do that. I'm Snigdha. All right, it's okay. I can be her. This is lecture 2. Clicker. Oh, I tried. Okay. Ah, now I'm connected. All right, question is up. You still can't get. Okay, talk to him. Yeah, here's another student who can't get on. All right. Right now I have like 70 answers. So I just like to point out that I really do kind of want to have good attendance here. It's good for you. It's good for me. So make a habit out of whipping out that laptop and answering these questions. Now this one here, I thought I had a wonderful distractor here in part C. So I thought everyone was going to go for C. And I was wrong. 2 people did. So why is it okay in this case that these instance fields are not private? Then a private class. No one else can see them because the class is private. All right. And so everyone, just about everyone, gave the correct answer A. that all methods of the address of the ArrayList address book class can construct and access item objects. They all can. That's why I put it at the class level and not in the method level. If you look over here, I have two choices. I can put it inside the class, I can put it inside the method, and I put it inside the class so that everyone in the class can access it. All right, excellent. Supposedly, well, let's, all right. In section 9.6, which is one of these testing track questions, it talks about mock objects. And so mock objects are very important use of interfaces where you can have multiple implementations of the same interface, one for testing and one for production. And so imagine that you're working on some project, as you soon will, with a team of students, not just yourself, but also a bunch of other people. Your job is to put the user interface for this address book thing. Your teammate's job is to produce the address book class. You don't want to wait for your teammate to hand you the class before you start doing your part and even testing your part. Because you know your teammate is always late. They always are. So what do? If you and your teammate agree that there is an interface address book, and then you can make a what's called a mock implementation of that interface that just does the most trivial thing possible. In the meantime, your teammate can work on the real address book that implements that interface, and you can already code against the mock address book, run your tests, make sure that the user interface looks pretty, while your teammate is working in parallel on the real thing. Eventually, your teammate will be done, and then you go to the line where it says address book book equals new mock address book, and you change it into address book book equals new ArrayList address book. And then you run your tests again, and hopefully now everything works better. Now if we look at the mock address book here, it implements load and save to do nothing, which probably then means that when you test your UI and when you save something and when you try to load it again later, you're not really going to see any changes. But that's okay. At least you know that the buttons were hooked up to the right methods and so on. And here, the same thing, put and remove do nothing. And every time that you ask the address book, give me some information about this name and this key, it's going to come back and say Fred, which means that your user interface, when you exercise it to look things up, you're going to see Fred, 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 Fred all over the screen. But that's okay. You can, your basic stuff works, and you're already able to make some progress. And of course, you can make the mock object a little bit smarter. Maybe you make it so that it just remembers the last thing that was stored, or whatever is required for a particular test. So it's incredibly useful for teamwork, where multiple people need to work on a program, that the person who is the consumer of some piece of technology can come up with a simple mock object, and the producer of the real thing later does it writing to the exact same interface. And then later one just swaps it out. Oh, and we have another clicker question, and set that up. Clicker. Poll choices A, B, C, D. All right, so All right, so by far the majority answer was answer B, and that is the correct answer, but maybe for a bit of a subtle reason. So if you look at if you look at these last two lines here, notice that on the left-hand side, it says address book. And on the right-hand side, it says, first it says mock, and later it says array list. And for this technique to work, it's really important that everywhere except in the constructor, you use the interface type. Like later on, there may be some method that takes an address book as a parameter. Make sure it takes an address book and not an array list address book or a mock address book. So as long as everything is address book, then you only have to change a single line, namely the constructor. And so that's the key thing here, that you want to program against the interface, against just the methods that you know the sucker must have, whatever it may be. And only when you construct it in that one single line does it matter which kind of address book it really is, the mock or the real thing. And so that's the power of interfaces, that you can design a contract and you can have multiple ways of fulfilling the contract and then swap them out on demand. So as an as another example of that, just as an experience, when I taught the software engineering class a couple of years ago, the people from the local movie festival approached us and said, we need someone to write us an application where moviegoers who go to the festival can see the festival catalog on their smartphone, which at the time was BlackBerry. It was 4 years ago. Time does fly. And and they said, and by the way, it has to be for free. And I said, well, hey, I'll just make that into the project for the software engineering class. And we learned very quickly that it is very, very difficult to debug things on a smartphone. Because, first of all, it takes some time to get it onto the phone, and then the phone is slow, and you can't really see any error messages. Like when you have a desktop application and it acts up, there's a good chance you get a stack trace. And that stack trace, as you know, right, tells you you had an array overflow here or there, or you did something wrong. On a smartphone, there is no stack trace. Like, depending on which smartphone it is, on the BlackBerry, there's some ugly icon that appears that says an internal error has happened. On the iPhone, what happens when there's an application error? The application gracefully fades into the background, right? But as a programmer, either way, you have no idea what went wrong, and it takes a lot of time to get at the logs, which you can with a lot of effort. And so what we did is and the other problem that we had when the Android came into the mix is we didn't want to write code twice for the BlackBerry and the Android. They were both Java-based, so we wanted to reuse code. But the way that the Android does things is completely different from the way that BlackBerry does things. You want to make a network connection, grab some stuff off the network, and then parse it. The interface it's the same idea. Get me the stuff from the network and parse it. But the implementations are very different. And so we ended up designing an interface that we called Platform that had about 20 services, such as grab stuff from the network, parse this XML file, put up this error dialog for the user, send this stuff to the server, log this message, about 20 of those, and we had 3 implementations, one for Android, one for BlackBerry, and one for desktop. That 3 classes that implemented the same platform interface, and it enabled us to do all of the back-end testing, all of the testing that was not very UI intensive on the desktop instead of on the devices. And with that, we were able to deliver the thing in about 3 months. Without that, it would have taken twice as long. So, so these things are incredibly powerful techniques. And so the reason that we're having a whole chapter on interfaces is they're just that important in real life. All right. Finally, the book has these nifty worked examples. They're not in the printed book, and the reason is that they're kind of long, and the publisher will not let you write a chapter that's kind of long-winded and goes on and on and on. You have to just make everything as compact as possible. But when you want to give a few extra examples, then you want to be able to be as long-winded as you like, and give some code, give some motivation, and so on. And so that's why we put them on PDFs. So I trust by now everyone has found out how to get them. There's plenty of traffic and desire to learn about the URLs. And so I have this one example here. I just want to have another example of an interface. It's a bit of an abstract idea, and the more examples you have, the better. So the example that I cooked up here is the example of a sequence. A sequence is a sequence of number, an infinite sequence of numbers that just keeps on going forever. And you have the sequence object, you ask next, you get the next one, you get the next one, you get the next one. You just get this infinite sequence of numbers, never stops. Some of those could be arithmetic, such as the sequence of squares that you have here. Some of them could be random, just called the random number generators. And so the worked example works through this where it tabulates the the last digit. So it looks at whatever, say a values to process is 100,000. You look at 100,000 numbers and you look at the last digit. So if you look at random numbers and you look at the last digit, so these are random numbers between 0 and 2 billion. And you look at the last digit. Are all digits equally likely? Yes, imagine in your mind 100,000 random numbers floating by. Only look at the last digit. Is it equally likely to get a 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9? So when you look at the chapter in the book, so the expectation is that you should actually run that code at home, and you should see. For the last digit, it is equally likely to get any digit. What about the first digit? This is actually something that you should try at the comfort of your home. There's an easy exercise, and it turns out the first digit, if you take any sequence of numbers, whether they're completely random numbers or whether they're numbers that occur in real life, you can try that out by picking, say, the areas of 100 countries. When you look at the first digit, they're not randomly distributed. It turns out that the low digits, 1, 2, 3, are much more likely than the high digits, 7, 8, 9. And so you've got to try that out. No one believes this. And you've just got to run the program and you'll see it with your own eyes. And people use this to detect accounting fraud. Because what a fraudulent accountant will do, when they cook up the books and they will feed in just numbers, just to columns of numbers for simulated sales or something, they will usually make those numbers up by hand so that they look random to them. And then they'll have a whole bunch of numbers that start with 1 and a whole bunch of numbers that start with 2, 3, 4, 5. And those numbers tend to have the first digit uniformly distributed. And so the people who check for accounting fraud will look at these patterns and say, hey, those numbers look too regular, because real numbers look regular in a different way. So it's actually kind of interesting. So the expectation is that when you look at that worked example, that you actually do get the code as well, and you run the code and see with your own eyes what goes on there. It takes you a few minutes to do it, so go ahead and do that. You get more out of those examples in that way. In the interest of time, we lost so much time, I'm going to not have this clicker question. You can look at it later. So let's move on to the lab. So I added more things onto Lab 1, so just so that everyone should be clear on this. So last time we were somewhere in E, and most people kind of got to this point, so I want you to continue here, and then I added parts G and H that were not there on Tuesday. So the lab for today is to finish F, G, and H. If you haven't even gotten to F, well then, keep on trucking. Now, a few of the buddies assignments have changed. So when you go to the buddies, which, by this time hopefully everyone is online. So I believe we kept most of them the same, but there's a few that have moved around for various reasons. So we'll again have to take a few minutes for you to find your buddies, and then we'll get going with the lab. Now, the one thing that this lab has, and I hope we get to this today, is in part H, I'm asking you to come up with some pseudocode to write that pseudocode on a sheet of paper. And those sheets of paper you need to hand to the front. Just drop them off here when you leave. Put your and your buddy's name on it, so that we can have a record of the pseudocode. You don't have to take a photo of it and upload it or anything. All right, let's get going. Yeah?